So the power reducing formulas that fall directly out of the double angle formula for cosine all deal with a second power, taking a second power and reducing it down to a first power. Okay. But we can actually use those power reducing formulas for any even power. And for any even power of any trig function, because we've derived the power reducing formulas for sine, cosine, and tangent, and of course the reciprocals of those would give us the power reducing formulas for their reciprocal functions. Okay. So here I'm asked to express cosine to the fourth of theta in terms of first powers of cosine. Okay. Now, I know that cosine to the fourth theta is cosine theta times cosine theta times cosine theta times cosine theta. That is not what the directions mean. That's a first power, that's a first power, that's a first power, that's a first power. But having four of them, I'm talking about a fourth power. When things are connected by multiplication, that affects the power. Terms, I don't think this is literally what in terms of means, but terms would be things that we add and subtract together. So I want to have first powers of cosine. It's okay if I'm adding them to other first powers of cosine, but not multiplying them together. That's cheap. That's not what those directions mean. Okay. But I am going to start by factoring this into two factors. I'm going to factor it into cosine squared theta times cosine squared theta, because I can use the power reducing formula for each one of these. Okay. Now I do accidentally have memorized the power reducing formula for cosine, but I'm going to pretend I don't, and I'm going to try and figure it out because it's a really quick derivation. Okay. I start with cosine of 2 theta, and I know that's cosine squared theta minus sine squared theta. That's the one that falls out of the sum formula. I can see that I don't care about any sine squareds because I just have cosine squared here. So I'm going to replace my sine squared with 1 minus cosine squared. And when I do that, I'm going to get 2 copies of cosine squared theta minus 1. Because of course that negative will distribute to the 1 and to the minus cosine squared theta. So then I would solve for cosine squared theta. So we'll have cosine of 2 theta plus 1, because we'll add this over, and then we'll divide by 2. So that's going to equal cosine squared theta. Okay. So it's a very, very quick derivation, which is kind of nice. And now I can say, okay, that means I've got 2 factors of this formula. Cosine 2 theta plus 1 over 2 times cosine 2 theta plus 1 over 2. Okay. So I've reduced things a bit, but I'm not done because these pieces are still connected by multiplication, and I know when I multiply out, powers can change. So what powers do I really have here? Well, let's see. If I multiply out the bottom, I'm going to get 2 times 2, which is 4. The top, we would have to FOIL out. So I would get cosine squared 2 theta. That's why I'm not done, because that's not a first power. Outsides and insides are both going to give me a copy of cosine 2 theta. So I'll have 2 of those. And then plus 1. Okay, excellent. Now I'm just going to distribute that division by 4. So I've got cosine squared 2 theta over 4 plus 2 cosine 2 theta over 4 plus 1/4. Now obviously I can reduce the 2 and the 4 here. I'll do that in a moment. But basically this term's just a number. This term involves, I'm sorry, that's a 2 theta right there. But that's a first power of cosine, just evaluated at 2 theta. This is the term that I really need to change. Okay. So let me just recopy what I have to clear up some board space. I'm going to just write that first term as 1/4 of cosine squared 2 theta. Okay, because I'm going to use the power reducing formula on this part. Once I've done that, I'll just multiply it by the 1/4. Okay. Plus, we said this reduces to cosine of 2 theta over 2 plus 1/4. Okay. In in the process of doing this, I erased the double angle formula, the power reducing formula, which I need to use again. So I'm just going to write it down again. Cosine squared, I'm going to just write of A instead of theta, just because I now have cosine squared of something other than just theta. Okay. But the formula was that it's cosine of 2A plus 1 over 2. I've just written it in terms of A instead of theta. Okay. So, okay, if I apply that here, we're going to have 1/4 of, this was cosine squared, the argument was 2 theta, I've got to double that. Well, if I double 2 theta, I'm going to get 4 theta. So this is going to be cosine of 4 theta plus 1 over 2. That's just using this formula where my A was 2 theta. Okay. And then I still have the plus cosine 2 theta over 2 plus 1/4. Okay. And so let's see. I'm going to just distribute. So I'm going to multiply out the cosine, the 1/4. So cosine of 4 theta plus 1 over 8 plus cosine 2 theta over 2 plus 1/4. And I think I'm going to take this just one step further, because I can see if I distribute this division by 8, I'm going to get another term that's just a constant. So I'll have cosine of 4 theta over 8 plus 1/8 plus cosine of 2 theta over 2 plus 1/4. And I can now combine those two constants. So I'll have just 3 relatively simple terms. So we'll have cosine of 4 theta over 8 plus cosine of 2 theta over 2 plus 1/4 would be 2/8 plus 1/8 would be 3/8. So now that's a sum, and each term is either a first power of cosine, or there are no cosines and it's just a constant.